basis of our work now is measuring contaminants in different media in the Great Lakes. In fact, behind us, I don't know if you can see it, we have some air samplers running. They're like big vacuum cleaners that suck the air, and we're trying to measure the contaminants that are in the air near the Great Lakes that might be depositing into the Great Lakes, settling to the bottom in the sediments, and then working their way up the food web to top predator fish like lake trout. And then people can eat fish and so on and ingest those same contaminants in their body and accumulate them in their bodies. So what we're trying to do in this particular project is sample all different parts of the food web, starting from the sediments and little macroinvertebrates and mysis, which are little tiny microscopic shrimp, and how those contaminants move up the food web to small fish, and then the bigger fish eat the smaller fish, and so on up the way. And these contaminants tend to accumulate in top predator species. So we're trying to figure out how it's happening and why it's happening, and answer some of those questions, because we're not really quite sure how that all works. Yeah, you know, when I was a kid, I was always interested in science, and my first love was astronomy, actually. And I guess I wanted to be an astronomer while I was growing up, so I enrolled in college as a physics major. And you have to take chemistry when you're a physics major, and chemistry just clicked with me. And I just seemed to have an affinity for it, and I just stayed with it and just kind of kept going piece by piece, day by day, and here we are now. Well, I graduated from college, and becoming a professor and going to graduate school was actually the last thing on my mind. I wanted to get a job so I could stop eating macaroni and cheese every night for dinner. So I got a job. I worked for 4 years in industry and for the Department of Environmental Conservation in New York State. And at that point, I got interested in, getting into research and so on. And I decided to quit my job and enroll in graduate school. Come into my office, and probably the first thing I do, like everybody nowadays, is look at your emails. And I'm probably getting ready for class. I may have a research student working in the lab that I might wander into and talk to them a little bit, see what they're going to be doing that day. Teach a class in analytical chemistry. Maybe in the afternoon teach a class in physical chemistry lab. After that, hang around a little bit, run some samples on my analytical instrumentation in my laboratory, go home, have some dinner, maybe come back in the evening and inject some samples and some instruments, get up the next morning and do it all over again. And it's a lot of fun. I work in gas chromatography, and that's a instrument that takes complex mixtures, you inject in the complex mixtures, and it separates it into all the different compounds and components, and it sends it to a special device we call a mass spectrometer, which we are able to, most of the time, figure out what the compound is. So we analyze fish, and we take extracts from fish, and we inject it in these instruments, these gas chromatographs. We can, most of the time, determine what contaminants are in them. So that's my go-to instrument. A passion for wondering how the world works around you. That's what you need. Everything else falls into place if you have that. Well, it's all about understanding the world around us and protecting our environment, and providing a clean place for our children and grandchildren, great-grandchildren to live. Follow your dreams. Do what you want to do. Don't do what your parents want you to do. Don't do what society wants you to do or what the television wants you to do. Follow your dreams. Do the things that you're interested in. That's what you're going to get satisfied in life, by doing something that really moves you, which for me is science. It's not for everyone, of course, but follow your dreams.